I welcome you to the first lesson, and today we will be discussing the physics of light. In general, why is light needed in photography? With the help of equipment, we can simulate natural, artificial, or practical light that is present on location. Also, add certain accents to the existing light, manage exposure, lower it, raise it, create a beautiful artistic composition, and generally take control of the entire image in our shoot. How can we primarily divide the types of lighting? It is natural lighting and artificial lighting. Natural lighting includes the sun, moonlight, fire, and lava. Artificial lighting includes lamps, light fixtures, location lighting, and outdoor lighting. Our main task when working with light is to ensure that our viewer does not realize that lighting equipment was used during the shoot. This means that we must be very careful and precise in our approach, making sure that every detail is perfect and seamless. That's why we need to understand the basic physics of light. So let's start figuring it out. For example, you need to simulate a sunny day on set. We are all accustomed to how locations look when lit by the sun, but have you ever wondered how this light pattern is actually formed? The sun is a source of hard light, which provides sharp beams, distinct shadows, and depending on the time of day and cloudiness, can have different temperatures. Some light is considered absolute, in terms of the quality of the light itself. But have you ever wondered why, even when the sun hasn't risen yet, or is hidden behind clouds, there is still light outside? Here is where the sky comes into play. The sky is an extremely important element often forgotten at the beginning of working with light. If the sun is a source of hard light, the sky, on the other hand, acts as a large source of soft fill light. Don't worry, we will discuss all these terms in more detail in the next videos. The sky, like the sun, can change its color and color temperature depending on the time of day and cloudiness. For example, on a clear day, the sun will have a temperature of 5,000 to 5,600 Kelvin, while the sky will be much cooler with a temperature of 6,500 to 7,000 Kelvin. Up to 7,000 Kelvin. Notice how snow looks in winter on a sunny day. In the sun, it is pure white, while in the shadows, it appears blue. This is related to the fact that the sky is cooler, while the sun has a warmer temperature. We have understood how the sun and sky work. But what happens to that light when it enters, for example, a room? Thanks to the reflections of light from the ceiling, walls, and even the floor, this light pattern is formed, which our brain and eyes are accustomed to. Does it sound like physics or natural science? Don't rush to conclusions. By understanding the DNA of light, we will eventually be able to apply this knowledge to create realistic schemes for daytime, evening, and even nighttime lighting. So, let's summarize. We can primarily divide light into artificial and natural. The sun is a source of hard light, while the sky is a huge softbox of fill light. All surfaces and objects we see reflect artificial or natural light, which is precisely what forms their characteristic pattern. In the next videos, we will apply this theoretical knowledge and see in practice how it all works.